Imagine you are standing on a beach. You cup your hands and scoop up a small mound of sand. The number of grains you're holding is roughly 10,000. Now, imagine that every single grain of sand on every beach and in every desert on the entire planet represents a star. That is a glimpse, a tiny fraction, of the number of stars just in our observable universe. Billions upon billions of them, and evidence suggests that most of those stars have planets. Billions of planets orbiting suns in our galaxy alone, many of them in the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist. Given these staggering numbers, it feels almost inevitable that life, and even intelligent life, must have arisen somewhere else. The universe is nearly 14 billion years old. Our planet is only a third of that age. That means other civilizations could have had a head start of millions, or even billions of years. So, a simple and profound question arises, one famously asked by the physicist Enrico Fermi during a casual lunch in 1950. If the universe is teeming with life, where is everybody? This is the heart of the Fermi Paradox, the stark, eerie contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for their existence. It's a question that transforms the silent night sky from a source of peaceful wonder into a deep and unsettling mystery. To understand this paradox, we first need to appreciate the sheer scale of the argument for life. The universe isn't just vast, it's ancient. For billions of years before our sun even ignited, countless other stars were born, lived, and died. If a civilization emerged on a planet just a tiny fraction of a percentage earlier in cosmic history than we did, say, a mere 50 million years, their technological evolution would be incomprehensible to us. A species with a 50 million year head start would not be just a little more advanced. The difference between them and us would be greater than the difference between us and the earliest single-celled organisms. Imagine such a species. After millions of years, they would have likely mastered energy on a planetary scale, then a stellar scale, perhaps even a galactic scale. They would be able to harness the entire output of their home star, build megastructures visible across light years, and colonize vast swaths of their galaxy. The evidence of their existence shouldn't be subtle. It should be loud, obvious, and everywhere. Their radio signals, intentional or not, would have been washing over our planet for eons. Their automated probes could have mapped every corner of the Milky Way, leaving a calling card on our moon or in our asteroid belt. Yet, when we look and listen, we find nothing. The heavens are silent. Our most powerful radio telescopes, pointed at the stars for decades in the search for extraterrestrial intelligence, have heard only the hiss of cosmic background radiation. There are no alien superhighways, no galactic empires, no beacons of light from distant star-forging engineers. This profound silence is what we call the Great Silence, and it demands an explanation. So, what does this all mean? The solutions to the Fermi Paradox fall into several broad and often chilling categories. Perhaps the simplest and loneliest answer is that we are, for all practical purposes, alone. This first possibility is often framed through the concept of the Great Filter. Imagine evolution as a long corridor with a series of doors. For a civilization like ours to emerge, a species must pass through every single one of these doors. A great filter is a door that is exceptionally, almost impossibly, difficult to get through. If a filter is strong enough, it might be the reason the universe is so quiet. One of the first, and possibly greatest filters, could be the origin of life itself. To understand this, we must look at the jump from non-living chemistry to the first self-replicating organism. We call this abiogenesis. While we have theories, we have never been able to replicate it in a lab. It could be that the specific sequence of events required to spark life, the right chemicals, the right temperature, the right energy source, all happening in the right order, is so fantastically improbable that it has only happened once in the entire history of our galaxy. In this scenario, the universe may be full of planets with oceans of organic soup, but they remain just that, lifeless chemical broth. If the leap to life is the great filter, then we are the first to have made it through. The silence isn't a mystery, it's just the sound of an empty cosmos. The pressure on humanity would be immense. We would be the sole bearers of consciousness in a galaxy of billions of stars, the only flicker of thought in an immense darkness. But what if simple life is common? What if the universe is teeming with microbes, algae, and simple organisms, but something else stops them from evolving further? This leads to a second possible great filter, the leap to complex multicellular life. On Earth, life remained as single cells for nearly 3 billion years. It took an incredible stroke of evolutionary luck, one cell engulfing another in a symbiotic relationship, to create the first complex eukaryotic cell, the ancestor of all plants, fungi, and animals. Perhaps this event is the true bottleneck. Maybe the cosmos is full of pond scum worlds, but they almost never evolve complex creatures capable of developing intelligence. And even if a species does become complex, is intelligence and tool use an inevitable outcome? The evolution of humanity was a product of countless contingent events, a specific climate change in Africa, a particular set of selection pressures, a mutation that allowed for a larger brain. Dinosaurs ruled the Earth for 150 million years and never built a radio telescope. It's possible that high-level intelligence and consciousness are not convergent goals of evolution, but are instead a bizarre and rare fluke. In this case, we might not be the only life, or even the only complex life, but we could be the only ones capable of asking the question, where is everybody? These first two filters are behind us. We pass through the door, but there is a third, more terrifying possibility. What if the great filter is not in our past, but in our future? This solution suggests that life, and even intelligence, might be common, but that the development of advanced technology inevitably leads to self-destruction. Once a species discovers things like nuclear fission, or develops uncontrolled artificial intelligence, or pollutes its home planet beyond the point of recovery, its lifespan as a technological civilization becomes tragically short. In this scenario, the sky is silent because no species lasts long enough to begin colonizing the stars. They flicker into existence, broadcast radio for a few centuries, and then, through war, accident, or negligence, they vanish. The galaxy becomes a cosmic graveyard, filled with the ruins of civilizations that failed their final test. If this is true, then the silence is not an answer, but a warning. It suggests that humanity is approaching its own great filter, and that our survival depends on navigating the immense dangers created by our own intelligence. We might be one of many fledgling civilizations, and the reason we don't hear from others is because none of them make it through the turbulent adolescence of technological discovery. Beyond the sobering idea of great filters, there are other, more exotic explanations for the silence. One is the zoo hypothesis. This theory suggests that advanced civilizations are out there, and they know we are here. But they have deliberately chosen not to make contact. They might be observing us for scientific study, or they might be enforcing a strict galactic policy of non-interference with primitive species like ours. We would be, in effect, a protected wildlife preserve. They might be waiting for us to achieve a certain level of technological or ethical maturity before revealing themselves. In this scenario, the silence is an artificial quarantine, a deliberate illusion. We aren't alone, we're just being watched from a distance by cosmic zookeepers. Another possibility is that we simply don't know how to listen. Our search has been almost exclusively for radio signals, a technology that is barely a century old. It's a bit like searching the ocean for whales by only listening for sounds in the narrow range of a human voice. An advanced civilization might be communicating through methods we can't even conceive of, like modulated neutrinos, gravitational waves, or some other physics we haven't discovered yet. The cosmic conversation could be happening all around us, but we lack the sensory organs to perceive it. Or perhaps they have moved beyond physical communication entirely. A sufficiently advanced species might have uploaded their consciousness into vast computational substrates, living in simulated realities where the petty concerns of galactic expansion are irrelevant. They may not be dead, just uninterested. In this estivation hypothesis, civilizations reach a point where they go dormant, choosing to wait for a colder, more energy-efficient future era of the universe to reawaken. The universe isn't empty, it's just sleeping. Ultimately, each potential solution to the Fermi Paradox acts as a mirror, reflecting our own hopes, fears, and sense of place in the cosmos. Are we the firstborn of the galaxy, destined to spread life and consciousness to the stars? Are we one of a long line of species who reached for the heavens only to be destroyed by their own creations? Or are we a young, developing species, being quietly observed by elders we cannot yet comprehend? The great silence leaves all possibilities on the table. It tells us that our story, the story of humanity, is unfolding against a backdrop of profound mystery. Whatever the answer is, whether the silence is a void, a warning, or a veil, it forces us to confront the value and fragility of our own existence. For now, we are a single, lonely voice, shouting questions into a vast, unblinking darkness, waiting for an echo that may never come.